In this video, we'll go over exercise H4, a W shape subjected to a combined axial compression and flexure load from the steel design examples according to the CSA S1614 codes, which is available for downloading at our website. Here's the exercise description. We will select a section which will carry an axial load in compression. The value for the dead load is 17 kilonewtons and the live load is 50 kilonewtons. The length of the member is 4.3 meters. The member will carry the following moments you guys see here in X and Y for dead load and live load. And the member will not be able to move laterally. For this exercise, we will be using a W250 by 49 steel section from the Canadian Steel database. Results of interest are based on the following load combination. Now let's jump into the demo part of the presentation. And here's the example model. Just taking a look at some of the properties. If we see the section properties, I have a W250 by 49 from the CISC 07 steel database. The material I'm using, if I right click, I'm using US Canadian Steel. You can see the properties of the material. In terms of supports, it cannot move laterally, and it's also constrained in these other degrees of freedom. If we take a look at the loads window, I see I have two load cases, and if I display these loads, I can see I have the axial and moments applied. If I move to the live load, you can see the values as described by the exercise. If we go to edit load combinations, you guys can see I have defined one load combination with the combination factors for dead load and live load. Now let's run an analysis for this model. Linear static just for the load combinations. Click OK. If we go back into our model, and here you can start checking the results for the load combination, like deflection, reaction, forces, etc. And once you're happy, you can go to STIL by clicking this command. Select your entire structure, in this case just this simple beam. Run a code check for the only load combination we have. I click OK. We get these results. If you like to access the details for the code checks, you just need to right click, go to code details to see the results for the different clauses. Comparing to our hand calculations, we're getting a CF value of 96, moment in FX of 88 for the bending stability check, and for moment in Y 11.5, rounded to 12. For the CR value, we have a calculated value of 988 kilonewtons, which is very close to the one calculated in STIL. The MRY value of 46.6, rounded to 47, as you guys can see here. For MRX, it's being calculated as 147. And if we move to the next page and just zoom a bit, for the axial compression and bending strength checks for cross-section, overall members, and lateral torsional buckling, we have the following values calculated in our hand calculations. The first value, we have 0.812, which represents 0.12% of difference when compared to STIL. The second value, 0.86, representing 0.11% difference when compared. And finally, 0.965, which gets us a 0.21 difference when compared to STIL. Thank you for watching, and for more tutorials and videos, please subscribe to our YouTube.